Okay, hello everybody. So right before I started recording, there was some questions about GUIs, and the next couple of examples are going to kind of talk about that. The next topic, as far as modules, was around inheritance and polymorphism, and I had a feeling that I was going to want to talk more about GUIs as we finish that one module that the class has about it, because user interface is kind of an important thing in software development. That's what we usually want to provide to people. So our example is going to continue that, and the next topic is where we ended the other day, had this segue into the next thing I want to talk about. So we're just going to do that right in the example. There were some questions about GUI show up, so I wanted to address those, make sure they're in the video. So normally when we go to put things in the GUI, we use the pack, we create our widgets and use pack or grid to set them up. The menu does have to be different. The top level menu, you have to use .config. So whatever you call the object, .config, and then pass in the menu, because the operating system itself handles the menu. That video that I sent an announcement out about Sunday, that's the story of where I finally learned exactly what was going on in that. So I had a problem and came up with a workaround and released the software, but 9 months later, it was 9 months later before I figured out why that workaround was the solution. I knew it worked and had already released the software, but that why that worked was kind of nagging it back in my mind for a long time. Sometimes that happens with programming. So that was one of the questions asked right before the video started. Another one related to mixing pack and grid. So we can use both of them, but not in the same place. So we'll draw, maybe we have this GUI up here or some section of a GUI. And we have a couple things that we want to put in. Maybe one of them is some box full of like check boxes. So we have this PK frame object, and we put a bunch of check boxes in that, along with a button. And all those are set up in this frame. And then we have another frame with just maybe a bunch of output labels. So it's like we organized our stuff before putting it on there, if that makes sense. And the output, and then the label where that output's going to go into. And we want to put both of these into our main content frame. This is the main one. And we have these options. We can use pack or grid, and place also falls under this. But my experience with place is kind of knowing that it exists. We have to keep track of all the pixels. With pack and grid, the sizing is handled internally. So we could use either one. I'll call this FRM in and FRM out to separate them. So when we go to put it in the menu, we could say FRM input dot pack, and yeah, there's some arguments we can pass in there, but if we don't pass in any arguments, it's going to center it, stick it right at the top, and fill up that space. But once we do that, we are restricted. So basically that very first time, that's saying, okay, we're going to pack things into our main frame. So at that point, if we came down here and tried to do the other one as a grid, and yeah, definitely have to have some arguments there. But if we tried to do that, we'd get an error. Because before it hit this instruction, we'd already kind of told the computer that we're going to pack things into our mainframe. So this one, once we start using one, we have to stick with it. So then we could pack that in underneath it. But I tried to draw it specifically here. So while this one is packed, like this one over here, I tried to put it in the picture to indicate that is set up as a grid. So we can put a grid inside of pack, or we could put pack inside of a grid. But when we go to put multiple things into something else, we can't interchange our methods. Does that answer your question, Kane?
Yeah.
So yeah, once we get to like, once we go to our container, once we start using one, we have to stick with it. So once, just finish out this example. If I said use, instead of packing that, put that first one in as a grid. Obviously, a bunch of arguments need to go in there. We've already divided our space up into rows and columns here. So then we can't use pack. We don't have a big open place to pack in afterwards. We've already divided it up into grids and columns, rows and columns. That one might be a better explanation for that question. So we can use both, but we are restricted that once we divide up a space, if we start packing things in there, we have to keep packing things in there. Or once we put the first thing in there as a grid, we've defined that space to have rows and columns. So it's no longer open to just pack things into. And that is a consistent thing across different GUI packages and different programming languages. We usually have lots of different methods, but once we start putting stuff into a container, that defines how that container is going to hold the stuff that we put in there. So then we kind of have to stick with that method. Any other questions about that? Just general clarification points on GUIs might be useful. Because like I was just saying, I'm going to stretch this out a little bit longer because it's something I feel is very, very important. We want to be able to make good graphical user interfaces for our end users. Y'all know how it goes. You've probably done this before. When you go look for a new piece of software, you can check like a best of list and start checking the things on that. And usually you're probably only going to give stuff a couple seconds. If you install it and open it up and don't like the look of it, or don't know what to do right off the bat, there's a good chance you're immediately going to go to the next thing on the list. And that's how most everybody is. Any other questions about just general things you encountered when putting that GUI assignment together or working on that? And yeah, there's no late penalty on that one. If you need more time to just study the concepts of GUI and practice on that, we'll take a little bit of time on that. Which I guess might make a nice segue to this next thing I have to point out. I mentioned that, well, I'd anticipated wanting to talk a little bit more about GUIs, which, yeah, now that we're here to the start of module 4 now. Yeah, the start of module 4. that is showing up, and it's like, yep, that anticipation was correct. So I share my screen. I'm talking about this here in just a second. And come over to our course thing, the assignment for module 4. Everybody's looked at this, you probably noticed something about this. Oh, the label's wrong. I gotta change the label, because the label, for some reason, unlike the other programming assignments, listed something out. That's what it originally was. I'm gonna get rid of that, because that was a somewhat trivial example. It was there wasn't anything relevant to that label it says. I had an example that used a 2-dimensional list to create a tic-tac-toe game, and it had absolutely nothing to do with inheritance polymorphism. So I'm gonna get rid of that assignment, but I haven't put a new one in yet. You'll notice the instructions are coming soon. But you'll also notice the due date. Switch over to the due date. I'll change that label on there. I forgot about that part. Doesn't have a date. Oh, there's the due date. That's due the day before spring break. I'm going to change that to after spring break, because there won't be anything else to do. So I'm going to switch that from the day before spring break to the day after spring break. And then the next assignment will be based off what we look at tonight and next week. So that assignment is going to get pushed back. Versus leave student. There we go. I thought that was already set for the Thursday after spring break, so I'll change that one around. But the programming assignment for this one, remember, our module 4 is not going to end until we get back from spring break, really, is when we move into module 5. So we've got still be time to do that, and I want to base it off the stuff we cover over the next couple days. The other thing that's pulled up here, just a reminder, if I go back to assignments. So remember that there is a new technology report due by the end of the semester. Just pick 3 technologies from within the last 6 months or so, advances in technology that seem interesting. And I noticed just a few minutes ago there was an interesting one come out very recently about using organic molecules to do a computer sort of storage. Some advancements in that. I was looking at the actual research report for class on the site phys.org. I'll point this out point this one out, so you may have heard me mention it before. This is a group out of Australia, and they basically do like a news report on all the latest scientific research to come out. So every time a research paper comes out, they write about it in layman's terms. But for some sciences, I'm going to get so simple. Even layman's terms for neuroscience, or layman's terms for advanced physics, only get so simple. Like submolecular physics only gets so simple. So they simplify what they can. So I like to go here, look at news, because humanity seems so much more promising looking at this. So about an hour ago, they released this story, which is new technology, something that seemed kind of interesting. So when I saw it, and yeah, this one does link right to the actual article. If you want to read about the actual article as well, but I'll put that in the chat room just as, and this seems like a good point to do that around the middle of the semester. Reminder that's coming up. So keep your eye out for new technology. It sounds interesting. It's a software development course, but it doesn't have to be software development. the goal of it is just to make sure that you're capable of keeping up on changes to the field. I thought that was really interesting. People have been working on that for a while. That's kind of what biological organisms do. They store data. So if we can take advantage of that and combine that with our computers, seems like there could be a lot of progress both ways. This and that. We're also open more doors for repair in that. I'll use that terminology, repairing it like we would a machine for healthcare concerns with people that might have genetic predispositions to disease or something. Opens a lot of doors, but storing data that way for computers to use is an interesting new technology. And that's what that report's about. So I thought I'd share that and remind you all to kind of keep an eye open for those things. So let's see, what else do I have in my notes? Homework for this module will not be due till after spring break, and which will actually mean, by the standard rhythm, the homework would be, that's a good one. Yeah, I just got a one in the chat, something in the chat room about some AI stuff. I just got a certification from Intel yesterday for some AI stuff. Yeah, I just got that certification. They make them very, very dark anymore. I guess because people don't print them much anymore, but I'm old. I like to print things and hang them on the wall. Probably burnt up all the toner in the printer to print something that dark, but AI can be a very interesting thing. So there's a lot of new technology. So that report, it should be very, very easy to come up with 3 things to put in that report. Even those of you all who have me for more than one class this semester. It should still be easy to come up with a bunch of interesting new things to write a paragraph about, basically. So yeah, so after the reminder of that was, yeah, that homework our normal pattern would have it on the Thursday when we get back from spring break. So we come back from spring break on Wednesday. So it'll be the Tuesday after that when the homework for this module is due. Which is going to be kind of based on what we do in the lecture this evening and next Tuesday, the following Thursday, and yeah, the next couple days. So it will be more GUI stuff, by the way. In other words, we're going to look at this stuff in terms of GUIs. We kind of talked about the concepts of inheritance and polymorphism. And I want to look at more stuff about GUIs. You probably noticed discrepancies in reference materials on the DK interface package stuff, right? You may notice that. Like sometimes it looks like it needs to be made into a class and then instantiate objects. And sometimes, other times, you'll see stuff where that wasn't done. I've been doing it not that way in class. And it kind of comes back to that criticism of event-driven programming we saw. Remember that difficult to extend? And that's one of the main concepts with object-oriented programming. We extend them into child classes. But graphical user interfaces get complicated and they're difficult to extend. The advantage that gives us is order does not matter. So when we were putting our class example together, doing a modular style, it wasn't a class, so it was very important that the methods are written up at the top of the file, well above any place we would call that. Otherwise, it wouldn't exist by the time we call it. Because remember, the Python interpreter goes line by line by line. So it starts at the top. And if we called that method at the top, but didn't find it till the bottom, it wouldn't know about it. But when we do the classes, those get compiled before they get ran. We create another thing out of it. So the interpreter is looking at the new one we created, but the entire class itself has already been compiled, so the interpreter can look anywhere in that compiled file. it's not just one instruction that was turned to machine language, it was an entire file. So the order does not matter if we do it with class notation. That's the big advantage there, because it's really hard to extend that, make child classes of it. The other advantage, kind of what I like to do, is subdivide our GUI into classes so that we can call up instances of it. So if I draw a picture of that one we've been working on here, have the status bar down at the bottom, main menu up top, our toolbar with the buttons, and then the primary and out content, the one we were looking at. We did it the other day at the end of class to talk about the importance of actually making alternate versions and comparing them. Anytime we have an appearance-based thing, it's often a good idea to go ahead and make several of them. That way you can pull them up side by side and actually see which one you like better. And it's not just trying to picture it in your mind before you actually do it. Which most of our programming languages, if you use that TK enter class, whoops, I can spell it right. That newer one, that does get styled with CSS. The standard from HTML5, the only programming place we have any sort of standards. But since there is a standard for how we apply colors and layout information in one place, we use that elsewhere. Most of our languages have GUI packages that work with cascading style sheets because it's a really good way to do something and be consistent. So if you do mostly the TK buttons instead of the TK buttons, you'll end up with styling with a CSS sheet, which actually goes in a method. You make a method and then all your CSS rules go in as one great big long string. The curly braces, the semicolons, and everything are just part of that string. Yeah, so really start a doc string and then type the CSS like you would anywhere else, and then end the doc string afterwards. But for the case of GUIs, you probably want to make 2 or 3 different style sheets. That way you can pull them up side by side and do a comparison, figure out which one's going to work best or looks best. But the main one we had was kind of setting up that employee, that stripped down employee sort of software. This became our class example. I decided to go with that because I figure everybody in here kind of has an idea about how jobs work and you can fill in the gaps. And anything we do for our class example is going to have to be stripped down for time examples. So I thought that would be a good way to fill in the one that might be easier to fill in the gaps with your imagination. So we put this notebook pane together. That's what we call the tabs in TK. And yeah, ours wasn't too complicated. It had a box there and a label. I think it just had another label for an output. But all of them were exactly the same. This is the sort of thing I like to do as classes. Because then we're going to do a whole bunch of these with only a slight difference in each one. And in our example so far, the only difference is one of them's for Bob, one of them's for Becky, one of them's for Sally, with those names we made up. If we went to hire another employee, we'd have to go hard code in a whole nother one. So it'd be nice if we could just generate those for however many employees there was. Right? There's 3 employees, we just generate 3 of those. If there's 30 employees, we generate 30 of those. That might get to be a mess in the tab panes, but for a class example, I thought that would be a good example of this. This is reused. So a good place for a class. can generalize it, generalize and repeat. We have those the general idea of what goes in the tab, and then all we need is the particular details for the tab we actually want to use. Leading in there, I want to take a moment to get it. I want to take a moment to get in there because I want to show a very powerful tool that our book doesn't even mention. Most books on Python don't mention it for some reason, and it's actually one of the best things about Python. One of the primary reasons that even the computer science researchers that spend all their time looking into what would make things more efficient really like about Python. So let's start with that little lead in. Oh, the first, I still have the class module up. I'm gonna point at something. Everybody in here has had Python before, so I know you've seen this, but I don't want to actually include stuff until we've talked about it in class. We'll come over here and come way down to module 5. It's over halfway through the class before we mention files and having data that would last for last. And I know everybody's seen it, so I want to go ahead and move it up. So I'm going to quickly talk about files so we can use that to easily generate the number of things we need. I know everybody's seen file writing. Yeah, I believe everybody in here has been there to see me go over file reading and writing files. I like to refer back to the old reel-to-reel tape machines. The file itself, our data, is in that tape moving between those two reels. Right? All the zeros, 1 1 0 0 1 1 1 0 0 1 1 0. Our data or the file itself is stored on that tape. Back in the old day, that was the origin of tape, eventually audio tape. Works really well for audio too. But we just put magnetic filings basically between two pieces of Scotch tape, and then those run past a series of magnets. One of those magnets is locked in place. It doesn't move at all. So if we activate that magnet and then run the tape past it, it's going to affect all those metal filings and it'll change how they're oriented because this magnet doesn't move. So it's going to change the orientation of the filings. So that would write stuff. There's another powerful magnet there. It's going to be on a spring, so it bounces. So the way, I'm assuming everybody's familiar with magnets, right? North and South pole, and similar poles repel each other. So like two north poles would push away, whereas a north and a south pole would be pulled together. So the polarity in the tape is going to make that one bounce up and down depending on whether it's attracted or repulsed for a particular bit. And that's our read head. And then both of these would go over to the actual memory with the vacuum tubes and powering heating coils, which would then melt mercury switches. Those heating coils would melt mercury to form a connection, and that's how that worked. We still have those type of switches. We don't use hazardous chemicals anymore. Instead of mercury, we have like a tube where those leads are open. And then there's one or two little aluminum or steel balls inside. So that if we turn that switch upward, those balls roll down and make a connection. The 2 is just so there's extra weight to push on, make it harder to bounce off. And if we turn that another way, it turns off. So it works the same as the old mercury switches, but it's not a toxic material. So much, much safer. They're really, really useful for, I guess they're most used anymore to tell if your robot fell over. You can just set a bunch of them up in different directions and tell whether your robot's standing upright or laying on its side or something. Anyway, back in the day, we do have all this. And this is our memory. That's where we work at. Which, while there's pictures here, relates to a point on the recent quizzes that I ended up putting the points back on because everybody in the class missed it. How was it worded? Those are the CPUs, the processor. Oh, and then for memory, that connects to our processor, which had the same thing. And back in the day, it was vertical instead of horizontal. Because the circuits were set up slightly different. But the question was, it said the CPU does the processing and it retrieves instructions from long-term storage. And then it had some examples, flash drive, the solid state. And that question's false because the CPU can only access memory. So the instructions come from long-term storage as a huge collection, as a program. Long-term storage holds a program, which is a whole bunch of instructions. And then the CPU can only handle one instruction at a time. So the reason that question was false is the program is in long-term storage, and then that is brought into RAM, and the CPU pulls instructions from RAM. I think I said that correctly, yes. Long-term storage has a program, a whole bunch of instructions. And even if there's only one, it's considered a collection with only one thing in it. I mean, like if we're writing Python or writing a program, we can have an array with only one thing. And it's not the same as a variable, right? We can't treat it like a variable even if there's only one thing there. So over in long-term storage, that's what we have. A whole bunch of instructions, and then we load all of them into memory or RAM. And then the CPU pulls the instructions from RAM one at a time. Whenever there's a question on the quizzes that everybody misses, I put the point back on and try to make sure that that point is clarified somewhere soon. And the picture for this evening helped to clarify that point. Because here's where we're working at in RAM and processing, memory and processing. Here's where our stuff's stored. The file is on the tape. So over here in our instructions, we don't have direct access to the tape. We have indirect access to that magnetic tape in this picture. And modern versions have equivalent to this. So what we can access is what the read and write heads are doing, not what's on the tape. So the modern version of that, and the reason I like to lead in with this picture, which I believe everybody's heard me talk about before, is what we can work with in our programming languages normally. When we say read and write a file, we're working with a file handler. There's a slight distinction between a file handler and the actual file, which we are going to see in the next module and make sure that distinction is very clear. I'm going to accentuate things to make it very clear why they don't work separately, but the file handler is basically the thing that can see our data. So memory or RAM, where we actually need that data to be, cannot even see the data. It can communicate with a handler, and the handler can see the data. I believe everybody's seen that before. In Python, there's a couple things. The easiest way is to use the open function. And then we pass in a string for the file path, and then a mode of how are we gonna access that file? Do we want to read it, write it, append to it, binary read or binary write? There's a bunch of them. The default is read. If we forget that second argument, it will automatically open the file for reading. When we do that, you want to go ahead and close the file. And there's a keyword in Python. We can say with instead of just that is assigned to some variable. If we use the keyword with, it will open all that as some name like handler, then a colon, and then we indent all the stuff that we want to do while that file is open. And it will automatically close and stuff. I prefer this syntax because it feels more like the normal Python thing for me. Keyword, something specific to our situation, then a colon, and then we indent everything. That's what feels like normal Python syntax to me, as opposed to just taking this open method and sticking that into a variable. But either way works. Yeah, that's probably enough for now. We're going to talk about files soon, but I didn't want to actually use that in class until we talk about it. So let's jump over and start looking at some examples. I'm going to make a stripped down new example to begin with first off, so we can see the point without all the clutter of what our regular example is built into. So again, I'm going to bring in that, just set up a little GUI. Oops. GUI is a tk.tk. So here's where we ask for that tk object. We'd also do something like this. And then in the constructor, I'm going to delete this part. I was just doing this because I know everybody has different preferences. And you should be at the point now where you're starting to kind of develop your own style. When you look at reference material, you don't have to do an exact copy of it. You can be like, okay, that reference, that tutorial site had a great explanation, but I don't like the way they write their variables. So I'm going to do it the way I do my stuff. So should be kind of working on that. And we all have different preferences. So there's different ways. I always do it this way. So, and separate the GUI from the class itself. You can also inherit from it. Multiple ways to reach the same result, and then we do all the normal constructor stuff, put in all our other methods. You'll know how that goes. Really, the difference, the advantage that gives is order doesn't matter for our functions, but it requires a whole lot more keywords to be there. So that's why I wanted to do the class examples the other way, because you all know what those keywords are. So if you want to do it that way, you know what those keywords are and where to put them. Or you should know what those keywords are and where to put them. So I was kind of viewing that as something that could be seen as excess clutter from the concepts we're going to look at here. Oh, then come down here and do GUI.main, which is enough to run this, right? Make a new folder. This will be a good start. Sure, Untitled.py, that's a good name for it. If I run that, that's enough to get our interface up. We've seen that a few times. We want to put some stuff on there, right? I'm just going to put some labels on there. And this is kind of what we did the other day. We have like label 1 equals tk.label. Stick it in the GUI, put the text for it. Obviously I'm gonna erase this here in a second. Just I want to do the steps along the way to see how we get to where we're going. And I'll just use back for now because that's quick and easy. Gives us a label on there. Got rid of all the extra space and stuff. Tries to fit it in there tight. You want to be careful doing that. The human eye uses white space to categorize and classify and group. So by the core principles of design, we looked at them the other day. Your contrasting point as far as usability, not necessarily color contrasting, usability is contrast is going to be handled by the white space spreading things out. So that's an important one, but for this trivial example, I'm going to skip past that. So maybe we have another one and some more. Probably want a few of those things, right? Want a few labels. Maybe we don't even know how many labels we want. We just know there's going to be a bunch of them. So I'm gonna first pass, I'm just gonna create a list and say, oh, let's go put a text file together. That way we can change how many we have very easily. I don't know, I'll use the same names as we were using on our other class example, because I wanted to kind of relate it to this. Just 3 names in a regular text file, nothing fancy there. I guess I hit the save button really quick to that. We'll put it in the blah blah folder, and this is list.txt. There you go. A text file with a couple names in them, a sequential data file. That would have been mentioned in several prerequisites for this course, so I believe everybody's familiar with that word. And we've talked about writing files now, so I don't mind using reading and writing files. Now that we've at least mentioned it, and we'll talk about it in detail in module 5, I think. Really, at that point, I want to focus on the ones you haven't seen yet, like binary files and pickling our data, and those times using the OS and OSPAT stuff, those times that we need to distinguish between whether we have the file or the file handler. When we can't talk about them interchangeably, I want to look at that stuff. So hopefully everybody remembers that. So to fill this list, we can just read from that file. I'll say that with open, I have no idea what I just called that. Oh, list.txt. With open the file list.txt for reading as handler. I just can't think of a word very quick, so I'll just call it handler. I most often use the words to file and from file just to help keep track of it, because we're usually going to have a bunch. But since we just talked about it, might as well use the proper term here. And now we want to add everything in that list, everything in that text file, list.txt, to our Python list, so that we can, to our labels list, which, as the name implies, probably needs to be a TK label object, not a string. So we've seen loops. So our for loop, the for loop in Python is what we call a for each loop in all our other languages. It automatically iterates through something. The for loop is set up to go through an iterable, something that is countable. That doesn't mean we know how many things are there. It means we know there is definitely a beginning and definitely an end to the thing we're looking at. There's a definite and a definite categorization to it. There's a natural place to break it down and split it up. For example, in a text file, the most natural place to split it up is per line. Each line in the text file is its own unique thing. So There's a natural spot to split it up. There's always going to be a definite beginning, definite end, so it's countable. We don't care what number we count up to, as long as we know that it's countable. That is, I guess that's an adjective. As an adjective, we know that adjective applies to it. We don't care about the particular act of counting it or the noun that we count up to. We just want to know that that adjective applies and it is countable. So our for each loop splits it up in a natural place. So we can say for each line in that file, which our handler can see the file. We can ask our handler, okay, read the next line, read the next line, read the next line, read the next line. It'll do it one at a time. We don't have to worry about numbers. It's just going to split about what it is. Then for each one, we can add it to our list. So I'll say labels, dot append. What are we going to append? A TK label object. It'll be loaded into that GUI because we don't have any other brains in this stripped down example. Only have one place to put it. One thing that could be the parent for it. And then the stuff in the file is what we actually want to show on that label. So that's going to be our text attribute. So our text attribute is going to be the line. Strip off any white space. Yeah, that'll work. Oh, we might need a selection there though. Whoops. I didn't mean to click that. I put a couple blank lines. So we don't want blank labels. So we should probably make sure we don't have a blank line to begin with. If line.strip is equal to the empty string, then we'll append it. That should give us a list that we can walk through. And yeah, then we have a list or an array or a collection of TK labels that we can put on our thing. So we can just loop through those. And the number there is completely dependent on that file. It doesn't have any dependence on our software itself. So for L in labels, L.pack with some padding. Add X equals 10, add Y equals 20. That'll work. Does everything there make sense? There's a very subtly a very important point for software development in that. Kind of what I have wrote up here on the board. Generalize and repeat. Okay, everything we've done so far with lists and really with our GUI the other day even, everything was hard coded in there. If we wanted something different, and like that shape GUI that was the homework that due today, but there's no late penalty on that. Please take your time and make sure that you understand all the concepts because it's a very important one for software development. If we wanted another shape, you have to hard code another shape in there, right? So I said, oh, I want octagons on there too. You have to go back, code in the formula for that, add another menu command for it, add another context menu command for it, add another button for the toolbar. For those who did, add another keyboard shortcut. For those who did the other one, the other extra credit point, add another command to draw a picture of that shape. And you'd have to go hard code all that stuff in. And the goal, when generalize and repeat. So when there's time, the thing we don't have in a classroom, you would probably do that hard coding first. But then you want to come back and clean that up. But for anything that you can put elsewhere, it's kind of like this. Say, is there anything that can be taken out of that input into a text file so we can just read it and change the text file and make our GUI adapt to the current state of the data without hard coding the program. Generalize, make it as generic as possible. There's nothing here really depends on that. I should run that and make sure I didn't get any typos. Yeah, I got a typo somewhere, didn't I? Wait, did I get a typo? I probably should have had my prep example open first. So where did I make a typo at? Oh. Anybody see the typo? I see it now, way before I got my example pulled up. I was like, I didn't open the prep example because there wasn't hardly anything there. Oh, I already put my cursor in that spot. Anybody see where the typo is? Accidentally only added it to the list if it's an empty string. I only want to add it to the list if it's not an empty string. That's probably a little more useful. Let's start running. Oh, the last one's still running. Stop the last one and then run this. There we go. So you can see it read from that file, brought that in, threw those labels on there. All that stuff should look familiar. If we needed to add another one, we can go right over to our text file, add in, maybe there's a David as well. I'm gonna run it again. Then we get that other label. So as our data changes, our GUI adapts to the changing data. That needs to be the goal. Oftentimes we want to hard code some stuff to begin with because that's a lot easier to debug. And as we get it debugged, generalize it and you start asking, okay, does this piece really have to be there? Or could we go get this from somewhere else? And try to make it so things don't depend on that. The next thing I want to do here is sort of the segue from where we left off the other day. Let me open that file from the other day. So we were using parallel arrays. So we're kind of set up to do this, right? There's all our employee data. Here's all our employee hours. Here's all our employee output spots. So it looks like we're kind of leaning that way. But that stuff had to be manually put in the list. We can do better, right? Kind of like what I was doing here. We read through that thing and put together a list. And what I'm about to talk about is probably going to look like we did almost the same thing. The inside is very, very different though. So I'm gonna stop this. Oh, I'm gonna erase the board. Is that okay? Everybody see what we're doing. We generalize our primary IO is what we're building up to. So that way we can just add more employees and then we get the tab for them and have their input box and it gets calculated with everything else. And look at applying a class somewhere. Instead of making the entire thing a class, we'll just single out part of the interface that we want to reuse. It's also incredibly useful for toolbars. We still see it some, LibreOffice has it. Go check out LibreOffice. They still have a toolbar. That's the one Apache's currently Apache's main release for Office software. But on that toolbar, you can turn sections of that toolbar on and off. And you can customize the toolbar to only the sections you want. The classes are very useful for that. We'll probably see that soon. So, next thing I want to talk about is a very important thing in Python that our textbook doesn't seem to mention. List comprehensions and generators. Almost the same thing. And what it ultimately amounts to is a way to filter data. Ultimately amounts to a way to filter data. And a note about appearance. When we go write the code for this here in a moment, after I talk about this, which is only a half page of yellow notes, we're going to copy and paste from that code we just typed. So it's going to look like we wrote the same thing. But it's very important do not confuse the code we write with the instruction the CPU runs. Okay. We're going to copy and paste from that code we just did in the example, put this together. So it's going to look like we wrote the same thing, but internally it's very, very different. And internally, this is much, much, much better thing to do. And it's one of the strongest points of Python. So we have a collection of things that we can look through, a list, dictionary, a file, anything that we can sort through. It could be sorted. We can create a new list from it. So have a collection. We can sort through and we have a collection we can loop through. A whole bunch of things. That's what a for loop does, right? There's for a list, for the items in the dictionary, for the lines in the file, for the files in a directory, for the directories in a directory, for the things that aren't directories in a directory. We can look through a whole bunch of files. We can go into directories. Okay, is there something in that folder that's not a file? That's not another folder? If there is, sort through it and sort through all the lines. So a collection of things that we can sort through. Loop through and create a new list. Or directly iterate through. Without saving. Yeah, I'll underline that again. So when we have when we do this and save our list, we're gonna call that a comprehension. When we directly iterate through it and don't save it, that's a generator. The situations where we use generators are a little more complex. Probably won't see a good one in class. Anything I could work into a class example would seem like we were using the range function. So before the range function, right, you probably use that a lot, right? For I and range, 1 through 20, stepping by 3 or something. You probably use that a lot. That's only been there that's only been around for a couple of years. It hasn't been there long at all. So before that, we use generators just to get a bunch of numbers in order. If we just wanted a whole bunch of numbers in order, we just manually made a generator. But then somebody came up with a really good way to do that in C++. So then we put together Python and put that in assembly language, very low level assembly language, not even the assembly language we usually read or that humans usually work with, and then included that in the Python stuff, and we call it. It's in the DLL files, so it's written in C. It's something in C++, not in Python. It's a really good way to do it. So we don't have to do this anymore. And then this is used for more complicated things. Like near the end of the semester, I'm going to send you an example, that match case thing that I was using, like a switch case, the new thing for 310. I've been waiting for switch case to find out for a long time because I'm just used to using that syntax. But that's not actually what it's for. It's for something more complicated. And near the end of the semester, I'm going to send you a bunch of videos on this YouTube channel that is not introductory level programming. So there's a whole lot of things that we'll need to talk about first before making sense of those videos. I was planning on starting that around week 10. So it won't be too long, but the stuff he does in some of those videos would make more sense to use a generator. Our class examples are going to be trivial for that. So you can think of something we can just iterate through the stuff without actually saving it. The difference for notation is square brackets or parentheses. So for a list comprehension, we use square brackets. So like I for I in range. I'll use the range function here. Range of 10 would give us a list of items 1 through 10. Save them all. For a generator, we do the same thing with parentheses instead of square brackets. Filter collection. I'm gonna put that on there for the notes. Because we're getting ready to see the example for actually using the syntax. I'll just put the concepts on the notes up here. Same thing down here, filter collection. And then we get that. I guess the biggest advantage of doing that is we can use a for loop for that structure. So I'm on the board here. Nope, not on the board there. So if we had something like X equals some generator, that's iterate through it, filter down the collection without saving the stuff. But then we could come back and redo that. So for Y in X, and then it's going to iterate through that generator. So I guess you could think of it as it saves the instructions, not the result of the instructions. Whereas the comprehension actually filters it down and saves the list. And then this is the big one to remember. Do not confuse the code we write with the instruction the CPU runs. So what we're getting ready to write, we're going to copy and paste those things we just typed a moment ago. So it looks the same to us, but it is every term you could think of to describe better for something moving through a CPU would apply to a comprehension over the for loop that is currently here. So what happens internally is very different than what we write in this case. And it's one of the biggest advantages of Python. So I'm going to copy out this. I guess it's going to get a little bit shorter. I'm going to create labels differently. So instead of doing that, so labels is still going to be a list. Instead of setting up a whole bunch of 1, 2, 3, 4, 5 lines of instructions for how to fill up that list, I'm going to put those instructions right in the initializer for that. Turn it into one line. So what do I need here? So what we actually want in our list is some TK objects, those labels. So what we actually want is we want to grab a TK dot label. It's going to be loaded into our GUI. So we're going to copy and paste from it. I already have this up here. So this is the thing we actually want. All of that was to get down to what we want. One. Loop. Filter. So that's the 3 steps we need. What do we actually want to get out of this comprehension? What do we want the Python language to try and make sense of from the data we're showing? And in this case, we want to loop through this. Oh, line's not defined. Well, that's part of our loop. So we need to define that. So we need that for line in open list.txt for writing. Oh, I've got to copy and paste again, but that's some copy and paste stuff from above. It's going to handle the handler and everything for us. We don't have to worry about that. And now we need our filter. No commas or anything, which the filter is the same. The only difference is I'll copy and paste this out. We don't need the colon at the end. There we go. Oh. So it looks like that. The thing we want, and we want to, or what do we want to do with the stuff we get after we filter it? In this case, we want to filter it down to the text in there. And then we're going to use that text to create a label. Then our loop, where we iterating through things. And then our filter itself. Only make a label out of it if, when we strip off all the white space we're left with more than just an empty string. So the same instructions should look familiar. Exact same, all those keywords and well, everything there was typed above. It's only one line of instructions now, But the biggest thing is that point I made here. Just because we type the same words does not mean the Python interpreter is going to turn that into the same bytecode, which then our operating system will turn into an assembly language that the CPU can then turn into machine level instructions. A different thing happens than what it was before, even though it looks the same to us. That looking the same to us makes helps it to make sense. But notice when I run it, it still behaves exactly the same. And that's too small. GUI.geometry. I believe I mentioned it. If I didn't, this thing 76. That big 432 times 234. That's a good size. Where we have a string of width x height. That is a standard across IT. You'll see that in lots and lots of different places. Whenever you write some code to ask for the string size, you will get back a string like that from any operating system you run the code on. That's a standard type of geometry object that we use. That is not a PK thing. There we go. I'm going to get the buttons and stuff. So you can see it still behaves exactly the same. There's nothing in our code that depends on this. And yeah, for that employee example, if we went and hired somebody else, like hired a Jenny and Anthony, I'm just making these names up. A bunch of Y's in this company. And that's a criteria for the interview. The owner likes names that end in Y. Oh, I've saved the file. Save the file. We should run it. Oh. Actually, that thing causes problems. There we go. The size should probably be a little more dynamic. You have to be careful with the size thing for that, because if you pass up the size, it's going to cut it off. But nothing, the data itself, or our GUI adapts to the data. And that thing right there, the list comprehension, is specifically for that. I think a generator would fail in this case. A generator would look the same, only in parentheses. And the big difference we would notice is over here in our in the list we create. I think this one's going to fail. I'm going to try it. I did right. But notice over in the variable explorer, before the one that said, probably could have pointed that out. Pointed out the thing I wanted you to look at before actually doing that. I'm going to the end of the line, make that back. So square brackets, so it's a list comprehension. We run that. Notice it says we have a list, and that list is filled with a label. It doesn't really have the details at that point. Then we can expand it and get it somewhere. But if I switch that to a generator and run that, we'll have to close it before it'll show. But you'll see there's no longer a list saved. So again, that one's noticeably more efficient. So we did the same thing. We grabbed the same data. The difference is we didn't keep it around wasting memory. It's like, okay, it's over there. We know where the file handler is. We can go get it when we need it. We don't need to just keep that around burning through all our memory. Can be useful to watch for things like that. So you can see both of them would work. It makes our stuff dynamic, And that would work really, really well for, oh, this is when we started. Obviously, this we would probably want to read in all the data at once. We need a whole bunch of stuff to initialize our objects. But this one, we can do that with a generator or a comprehension. We do that with the generator and not keep that stuff around. Just grab that text and as quick as we grab it, move it, put it somewhere else. We don't need to store it in multiple places. If it's going to show on the screen, we can read it from there later if we need it. Same thing here. Those are some output things, so we can just grab them if we need them. Maybe add in that little filter condition that if the string related to it is not empty, something like that. So that was kind of the next step, but we've already been at this for an hour and 20 minutes, and right now there's 30 minutes left of our class time, a good lab session. So that would be my recommendation for our lab time this evening. Is that one from the other day is on GitHub. See if you can change those over to list comprehensions or generators, or use some of your own software. You probably understand that better than the way you watch me make. And I was talking the whole time, right? If you thought about it and put that code together, you probably have a much better understanding of it. Because computers don't process in the same way we think. So it also relates to it doesn't work the same as the English language, so sometimes it's kind of hard to put into words. But 30 minutes, try messing around with those and using list generators. So the thing we want, what we're going to loop through, and then the thing we're going to filter. And keep it around. And parentheses. The thing we want. Loop through our collection and filter. I'll say filter as needed or grab as needed. Those are good descriptions on those. Very, very useful things. That is one of the most powerful tools in Python. We can nest those. Yeah, I'll just jump over to GitHub real quick and show you some nested ones of those. I know I have an example somewhere, and I'll upload that to the GitHub manually today. Add file, upload files, recommends, delete. So that new stuff is in the folder called blah blah. On the thing today. Oh, whoops. I don't like that menu. I like the home page. And I don't know how to get back to a page that has them listed like this. Oh, this one I know does. So, I know Mark's seen this before. So this is the instructions on how to draw a three-dimensional human in Python. We go up a little. I think I have a picture of it. Yes. To save a bit of time, all the starting points, all the proportions are correct. It's averages. That is exactly proportional to every average. If you look at a human, average finger length, average length between knuckles, averages on the chin. So then all an artist has to come in and do is come in and start adding in details. And they don't have to spend the first hour and a half just working on that general shape. The artist can just jump to it and start adding details, and that adds another hour or two that the artist can spend adding details. for a bunch of different species. So the general shape of a human, here's what that looks like. The instructions to do that in Python, along with some other stuff. Here's another way to do a manifest that we haven't done. You can see that's a little bit harder in stuff in manifest. That connects to another file in the manifest, but the one we're looking at, the requirements and the init file, those are easy ways. So we have these instructions. I turn word wrap on somewhere. We're going to edit this file. Nope. Can't do that with edit. Oh, yes. Software. So you can see there's a whole lot of little points to find the three-dimensional space to do that. I have to scroll for a long time to do that. It's already in line, you can't really see it. But obviously, I did not go and type those in Python. What I did is I spent a while drawing that. And I'm pretty sure I have the script here. And then I used some list comprehensions to grab all the vertices and faces from that shape. So here's the code that did that. I spent a while drawing that and the model, making that model. And then the list is just, the instructions are just a couple of comprehensions. So a vertex for the vertexes in the object that's selected. So a list comprehension of all the vertices, which is a thing that we can iterate through. It's a collection. That's definitely not a list or dictionary or any of the ones you're used to in Python, but it is something that there's a definite first one and a definite last one and a clear separation between them. So it's iterable. And write that to a file. Then you'll see down here, there's a nested one. So for the thing we want is a list comprehension. So nesting goes like that. So a list comprehension is the want part out of it, and then we go into the loop part. And there's no filtering because in this case I just grabbed every single one. It's like, yeah, I want every face in that model. Definitely don't leave any of the polygons off. But a very, very, very powerful tool. Those lines right there are what wrote that big script over here. And more. Let's look at a different one. Just look at humans. So bullfrog. So the same thing for how to write the starting point for what a bullfrog looks like. The important thing to have in the back as a background in the video games, right? Probably wouldn't spend a lot of time on details on that because it's going to be a small thing hopping around in the background of a video game. But you still want it to look accurate and proportioned correctly and all that. So save some time for artists is what that's about. And again, the reason I was going here is to show you that nesting, like we're used to do, we're used to nesting loops, kind of works the same. It just goes in a different position. But one of our most powerful tools, and I just talked for a few minutes about doing that. You can see that example we did in class is on the GitHub page now. Definitely my recommendation for the next 25 minutes now, I guess, of lab time. The homework for this, the next homework assignment coming up will involve list comprehensions and generators. So expect that, but it's not going to be due until after spring break. And it's going to be based off what we covered tonight and next week. What we cover between now and spring break. And then it'll be a couple days after that. So there'll be a minute before we have more homework. So it's a good time to just randomly do random stuff in Python to practice and hone your skills. And this, what we saw tonight is a very critical one. Was that everything on my list? Small example usage. Oh yeah, and then we're gonna look at those again to expand our example next Tuesday. But I'll have that ready, and by then, assume you will have seen playground with list comprehensions a little on your own. So we'll probably go through that part really quick and then get into the inheritance on our example, so we can set up a class and make use a whole bunch of those. Any questions? Oh, that was a lot of different stuff. Okay, I assume the silence means no questions. So y'all have a great weekend. If you have any questions, let me know. I'm always happy to help, and I will see you all on Tuesday.